So I'm Sebastian Sa. I'm the Associate Director of Agricultural Research at the Almond Board. And I'm today the moderator of soil chemistry. So soil chemistry, quite an exciting topic. I think we're going to be talking today about soil amendments, so like gypsum, how to interpret a soil analysis. We're also going to talk about nutrient management, like Nutrien BMPs, episodic versus continuum, and so on. So I think there are a lot of topics that are going to be floating around. And to that end, we have put together a set of speakers that they are all really experts in this area. We're going to start with Blake Sanden here from the University of California. Then we're going to move to Jerome Pier, Senior Agronomist of QualiTech Plant Nutrition. Then Tom Bottoms, manager and partner of Timothy and Veggie Farming at El Molino Farms. And ultimately, Daniel Casaplacio, Senior Agronomist at the Valley Laboratory. So the rules of the game, so they are going to be sharing a couple of key messages with all of you for the first 5 minutes each of them. So 5 to 10 minutes to share some key messages. There are some handouts that they prepare for you as well. And then really open it for questions and answers. So with that quick introduction, Blake, you can go first.
Thanks, Sebastian. Okay. Wake up. As I was walking in, I saw a couple pickups with quads in the back. Great. You're going to get out, see what's out there. How many of you also have a soil probe in your pickup? Oh, good. Almost a dozen people. The rest of you jerks, if you're serious about what we're talking about today, then you're going to remedy that problem. I like this hammer probe from Arts Manufacturing because there's a lot of tough soil down in Kern County that aren't always easy to get into. Okay, with that.
Put your weapon down.
Yeah.
Oh, I feel safer now.
I was told by Sebastian we could not do death by PowerPoint. And so to that end, because of the complexity of what we're talking about, I put together this handout. And you will find for the next 5 minutes of my palaver here, it would be really helpful to pull this white sheet out. Before I get into this white sheet real quick, I just want to say that a big deal of what we're talking about in this conference is soil health and soil amendments. Here's the original soil amendment, roots. And the management of cover crops is an art form that has kind of been put aside for too many decades. I think we're doing a better job of coming back on that. But this cover crop publication done by some of my brothers and sisters from the UC system says nothing about the potential benefit for infiltration, which was one of the earliest studies people did 60 years ago on improving soil aggregation and health. If you got a saline soil, depending on the mineralogy, depending on the cover crop, you can improve that infiltration by as much as 50%. So with that, take out the white sheet, and I'm going to just hit some high points because our intention with this panel is to throw out a few nuggets in hopefully a few minutes and generate your interest to come back with your particular problems to take our, more than a century's worth of experience and see if we can talk about it. Okay, the very first top table is a typical soil analysis that I like to see. Now, why do I like this? This fits nicely into an Excel spreadsheet. Well, why the hell do I want to put my soil analyses in the Excel spreadsheet? How many of you use Excel to create your irrigation schedules? To track your pesticide usage? Wow. Most of the rest of you are just farming by your butt, huh? Okay, well, the reason for this is there's calculations we can do to get a starting point on how to manage excess salts, on how to understand where our infiltration's at. So I like this format, which is an easy dump into Excel. This is a common format that Delaware Valley Labs provides, and you can very quickly get an understanding of just what the salt level is and your nutrient levels as you go down through the profile. So if you look at this particular sample, I'm not doing every foot. I'm doing 0 to 20, 20 to 40, 40 to 60. Why? Because I'm a cheap ass. I want to get down to 5 foot, and those 3 samples do that more cheaply for me than the 5 samples. And for most of our soils, that's absolutely enough resolution. Look at the 20 to 40 inch sample here, and you can see the salt doubles right there. And then below that, 40 to 60, boom, you get into sand that's not got next to no salt in it. And why is that? It's because this field had a severe infiltration problem. The water's only going down to about 3 foot. And so what do I do when I look at the assessment of what impact that has on my yield? If you go down below the next 2 tables and you look at the bold right there, that's a relative yield formula. This is using what we have as our beginning standpoint for assessing ground that might be problematic for either development, or if you've got a current orchard and you're seeing defoliation, you're seeing burn around the leaves, just how bad might that impact me? So you can take these relative yield thresholds and a % decline with increasing salt, and you can calculate a potential relative yield. And this came out to be 64% for this field, and that actually was about right compared to his neighbors and compared to his other field that didn't have that infiltration problem. So this is not an absolutely pure, hard and fast model that's going to give you the exact number for your field, but that's a starting point to really let you know if you're in the not too bad or you've really gone over the oh shit line. That's what I've done is I've just put a lot of what we consider to be our starting point thresholds as recognized really over the last 40 years, published by FAO. And then on the back of the sheet, if you take a look, there's a rather complicated table up there. That gives you the equivalent, for a release of 1 milliequivalent per liter calcium in the water, that's an extra 20 part per million milligram per liter free calcium. It takes you 234 pounds of 100% gypsum. And it gives you the effective release from acid and polysulfide. There's a lot of different amendments right there. And right below that, you can see a web link. I have these different calculation tools in Excel. So some of you guys that may not be able to use it, I don't know. But that web link will let you go into my models of different worksheets that will show you how to do some of these calculations that are in here. The last thing I want to point out to is, okay, we got these models. How much do they really tell us about reality? Look at the bottom 2 graphs. You see there's a whole bunch of scatter on the right-hand one. There's less scatter on the left-hand one. And that line that's in the middle of that, of those 2 graphs, that is that classic 1.5 ECE soil salinity threshold for no yield reduction. And basically that applies to Nemogard rootstocks. It does not strictly apply to the newer hybrids and the Brights and the Hanson. At any rate, you look at 1.5, and then the decline line is the 19% decline for every point you see over that. And on the left-hand side of the graph, you go, whoa, okay, most of those trees fell within that threshold. They've got an average root zone salinity of less than 1.5. But look over to the right-hand side of the graph. You got 3, 4 trees out there that are pushing an EC that's more than double that threshold, and they're still kicking out 4,000 pounds, and they're Nemagard rootstocks. Why is that? I don't know. I really don't know. There is nothing more variable on this planet than dirt that was created by God. And that's where the art of your farming comes in, and management skills, and the variety of cover crops, amendments, things that we're using to turn that out. Now, look at the chart on the right side. Now, whoa, what's going on here? You see there's a whole bunch more dots that are over to that salty region of going 3 to 5 EC. Okay, Tom, I'm done. What's that scatter all about? This is the average root zone to 5 feet. The other one's the average root zone to 3 feet. And 3 feet, we can all agree, is where most of the action happens. But my neutron probe extraction showed 30 to 35% of the water those trees used over the season came from the 3 to 5 foot depth. This is beautiful soil. I mean, obviously, I'm kicking out 4,000 pound plus almonds. It's got to be good dirt, right? And good management, good scheduling. This was from the Patrick Brown nitrogen potassium trials. So the reality is all of our best estimates and calculators are just a starting point. And it's going to take you pounding in the dirt with the probe. It's going to take using tools like cover crops. Now we've got whole orchard recycling mandated. All that's going to affect the benefit of water movement and nutrient movement through the dirt. Jerome, you're on? Okay.
100 years, you guys. You think we got 100 years? I think Blake is pushing 100 years, but just by himself. But it is an honor to be up here with these fine gentlemen. You know, I think the one thing that I would say differently is don't be a cheap ass when you take your soil samples. That's the only thing I would argue is that, okay, with the price of land, with the water that we're dealing with the price of fertilizer, and I don't know, do you think fertilizer prices are going to come down anytime soon? Probably not. So why are you going cheap with your soil sampling? And take a water sample. Understand your water chemistry. You know, we're up here to talk about soil chemistry. Well, if you don't measure it and if you don't understand it, then you're just flying blind. You're basically driving a Ferrari with your eyes closed, you know, and not looking at the speedometer. I mean, it's ridiculous. So you really, you know, using Blake's weapon, you need to go out there and really take a good stratified sample, use the tools that we have available, the soil web survey to understand where your soil textural changes are taking place. You know, if you want to go out and grid sample and get crazy, we do have people that are doing that, and they get a lot of information to understand the variability within the field. But also zone sampling is quite appropriate, just knowing where your textural changes are taking place. But you really want to look at the stratification in that profile before you ever plant. I mean, the whole goal here is we're going to put almonds everywhere we possibly can. I mean, in the beginning of my career, there was cotton, there was alfalfa. It's all almonds all the time. I've had soil reports come in where the guy is like, you know, I got to put almonds here. And I'm like, almonds do not belong here, sir. There's just no way. I'm like, I will plant almonds. I've already ordered the trees. And I'm like, that's completely insane. So let's figure out what we need to do. Without that soil test, without understanding the stratification in your profile, as Blake pointed out in this one example here, you may have a textural change, a distinct textural change, which will prevent that free drainage from taking place. And even though we're using more sophisticated irrigation methods with drip irrigation, we have ways to monitor what we're doing. You know, farmers are doing a much better job with the water than they ever did when they were flooding. You know, the duck pond irrigation of the old days is going away, and now we've got this dual line drip that can do amazing things. But even in that situation, if you get those textural changes and you don't understand the soil that you're dealing with, you can get a salt buildup and you don't have free drainage of things that are going to cause issues down the road. So, you know, this is the thing. I mean, we've got people, if the field doesn't already have almonds in it, you know, then that's where all your best soil was. You know, it's either got houses or almonds on it now, right? So everything that's left is challenging soil, challenging water. And get that water sample, spend the money, get a lot of samples out of the field. Don't just go down to 18 inches. Use the weapon and go out there and take 1 foot, 2 foot, 3 foot samples. And when you go send your sample into the lab, get a complete analysis. Don't just get your base cations and, you know, get the whole thing, saturated paste, base cations, get the full nutritional package, and look at some of these options that Carl mentioned, you know, the biological capacity of that soil. You know, what was the previous crop that was in there? You know, what is the history? Try to get as much information as you can, because the money you just spent on that sample is nothing compared to what you're going to be spending. And to try to get that orchard off to the best start it possibly can and have every tree be as uniform as possible is where your greatest yield potential is going to be, and that's where you're going to get your biggest return on investment. And if you just cheap out and don't spend it on all that information, then you're really starting blind, and you're never going to get the kind of productivity that you're looking for. So we want those 4,000-pound crops, and you're never going to do it without information. So that would be my only caveat to what you've presented there. So yeah, it's all about sampling, aerial imagery. You know, use all the tools that are out there. The web survey, I think, has been a great thing. You've got it on your phone, iPad, whatever. You know, we've got GPS everywhere we go now. I mean, you know where to sample at this point, and there's no excuse. I mean, even in Hawaii, they now have soil web surveys, so you can sample just about anywhere and know what you're dealing with, because you are going to be dealing with challenging soils from here on in. That's all we've got left. So I know I've probably overstayed my welcome. Oh, I'm just about 5 minutes. So I'm going to leave it to my colleague here, Tom, and he's going to take over. Thank you.
Thanks, guys. I don't know if I fit into this 100-year experience. And I'm just going to, and these guys know a lot more than I do. I'm going to tell you what I've seen on our operation and what we're facing. You know, in the past, we've fertilized. I'm going to talk a lot about fertilizer. We fertilized based primarily on reducing environmental losses. I think this year's is proven different, right? Where we say we've had these, in the past, we've had these higher prices, and these higher prices have caused us to, if we need to put more fertilizer, we do it to make sure that we get to the yields that we need. As prices have gone down, whether it be shipping or just the huge inventory that we have, it's caused us to think differently about how we fertilize. I mean, I've got a spreadsheet here of all the fertilizer costs that we have, that we're experiencing right now, and when we go from $350 a ton for UN32 to $750, $800 in 6 months, it changes the way we farm. So, and then we had that, and then we had this hold my beer moment where we had this frost that decimates a crop, right? And so we say, okay, where we have a crop that we typically know how to fertilize, our yield estimates have gone out the window. And so we figure we're in a position now where we could either throw up our hands and just file an insurance claim, or we can really try to dial this in. Now, we're primarily row crop growers, and so if you need to know what it's like to file insurance claims, come on over. I'll show you what it's like. We'll be okay because we do it a lot, and this year we'll be able to do it on the trees, which is something. So I'm going to talk just a little bit about just young trees and what I'm seeing in young trees, and then in our older orchards as well. I think for the young trees, what I think I'm going to prescribe to is probably the best fertilization program for our young trees is a really good irrigation program. I feel like I'm going to speak for myself. I have screwed more orchards up irrigating incorrectly than fertilizing incorrectly. And so I'm based between Davis and Dixon, and those are a little bit heavier soils, and so that's, I don't say that's tougher to irrigate, but it's different. And so we've really been able to dial that in. Historically, going back to the 60s, 70s, what they used to say was 1 ounce per tree, 1 ounce of nitrogen per tree. I think that what we've seen is David Dahl and many others have shown that it's actually more than that. It turns out to be closer to 3 to 4 ounces per tree of nitrogen, which is the equivalent of 30 to 35 pounds of nitrogen, which is what is recommended. And I'm going to throw this plug in. This nitrogen practice by the Almond Board is fantastic. So take a look at that, and it kind of describes those numbers. But I think what they did have right, what was done right, was that it needs to be split up. Instead of the 3 to 4 ounces per tree put on in one shot, I think the transition that we're seeing in our operation is really trying to apply as frequently as possible. Maintain the soil moisture instead of large shots of water, but also instead of that, really trying to put on smaller, frequent doses. Not in the sense of the fear was always we're gonna get the shallow root system, we're not gonna put deep moisture. I think that's changed a lot. How we irrigate, how we fertilize has changed a lot, and so we're putting in a lot of frequent shots. So the 1 ounce per tree might be true, but it's 1 ounce per tree per application over 3 or 4 applications every 3 or 4 weeks. And so we change our mindset, and I think this has been driven now for us, driven a lot by prices and environmental controls. Also watching the form that we're putting on. So I've seen, yeah.
That's for growing baby trees.
This is it, right there, right.
So now you've got a mature orchard
Yeah,
that frosted out.
yeah,
How would you handle your nitrogen?
yeah. Wait for it. Just kidding. I'm sorry, I'm getting there. I have to like prepare. These guys can do it off the top of their head. I've got to write stuff out. I'm like, I don't know that. No. Real quick on the form, and on young trees, we've seen that we can almost have deficiencies of nitrogen depending on the form. If we put on large shots of water and we put on a nitrate-based fertilizer in a lighter ground, we can lose that. That root system on those young trees is pretty shallow. And so if you're going to use a nitrate-based fertilizer, now there's a number of products, and this is why a lot of people have wanted to use dry products around each individual tree or use these different slow-release products to keep that in the shallow root system, or to keep that there where the trees can use it. It's got to be really careful with those, with a nitrate-based product. Now, in the summer, that UN32 is obviously nitrifying to nitrate really quickly, and so it's the same issue, but really trying to pay attention to what that looks like. For the older trees, what we know from older trees is that the trees do not use nitrogen in the soil until about 70% leaf out. Up until that point, they're using nitrogen from the stored organs. For me, as a semi-researcher, not really, as a grower, right, I think there's no way. I'm a row crop grower. I grow tomatoes. I know that I've got to put that there for the plant to use it. But it's patience, right? Now, at that 70%, if you don't have something available, you could have problems, right? And so you have to think, at 70%, I need to have nitrogen available in the soil. And that needs to be available in the nitrate form. If that needs to be in the nitrate form, and if I'm going to use UN32, I've got to make sure that's there, and it's already nitrified to a point where the plant can use it. That process is driven by moisture and temperature, primarily temperature at this time of year, and so you need to make sure that that's there. Thus, why we know a lot of people who put nitrate as their first form of fertilizer that's applied to the older trees. In terms of nitrogen, and there's a number of percentages of how much nitrogen is used throughout the season, transpiration drives nutrient uptake. look at what the trees, how much water the trees are using. If the trees are using water, they're taking up nutrients. So we've really transitioned to very frequent fertilizer applications. Instead of doing it once a month, right, we're transitioning to once, twice a week. There's programs to do this. We've just developed a structure, a system with our employees that we just get used to applying fertilizer very frequently. We've been able to reduce the amount of nitrogen we apply. Then there's this myth of stopping fertilizer, and I say a myth, stopping fertilizer early to not have to stop hull rot. Nitrogen applications and nitrogen use in trees has changed, or how we think about it. We can fertilize throughout the whole season up until post-harvest, or even to post-harvest. We've seen higher, and I mean, folks from Yara and others have shown that there's higher incidence of hull rot stopping, putting on higher amounts of nitrogen and stopping and having issues with hull rot later on. We're not afraid to put on nitrogen later through up until post-harvest. Because these large slugs of nitrogen, it's not happening. It's frequent, meeting crop and plant need. So a few takeaways on, I guess, that we've developed systems and automated and so that we can apply fertilizer frequently, having many applications of fertilizer through the season. This year in particular, we need to be really trying to estimate yield. If I look at my nitrogen budget and I say, okay, I'm going to end up spending, if I were to apply 250 pounds of N, which is a healthy amount of nitrogen, that's going to cost me $270 an acre. If I can reduce that by 5%, that's about $15 an acre. And if I can reduce it by 10%, that's almost $30 an acre. I know that our yield estimations are on some of these orchards are 50% of what it was, or 80% lower. If I can take that down off the fertilizer, and that's just the nitrogen and the potassium, which is really similar, that's a huge amount of money. And so we're really trying to pay attention to what, if we've got to try to estimate yield, see what is on that crop. And I know you guys are battling with it too, and it's challenging. And then never before we felt like we need to get this irrigation systems dialed in terms of distribution uniformity. It's the same for the water as it is the fertilizer in our case. And so really spending a lot of time focusing on that. It's been huge. I will say the Healthy Soils and the SWEEP programs that CDFA has put together have been fantastic and helped us out on a number of different levels. But getting those irrigation systems right has been a big deal. So yeah, go ahead.
Well, first an applause to Tom. Thanks a lot. And as we move to, I feel empowered here with this as a moderator, you know. As we move to the last speaker, you know, the previous speaker has thrown so many good concepts here. So please start thinking on your questions. You know, they had talked about episodic versus continuous fertigation, different sources, leaf sampling, soil sampling, the great handout that Blake put together for you guys. So there's a lot to talk about. So as Danielle is talking now, start also thinking about your questions.
Okay. Well, I just cannot resist the temptation to tell Blake not to be a cheap ass. Shouldn't talk about your esteemed clients like that, but I just couldn't resist. It's a great handout that he put together here. But one thing that I would really, when looking at these numbers, and I know up, you know, northern Sacramento Valley, we really don't have salinity problems like we have in the South San Joaquin Valley. But looking at that salinity profile, you see that there's this big salt accumulation at 20 to 40 inches. Now, me personally, I would like to have a little bit more detail on where that is, because maybe from 20 to 30 inches, it's the same as from 0 to 20, and all those salts are accumulating from 30 to 40. And so you really need to have a little bit more detail. But this is a great start, and one can always go a little further. And a lot of times when doing due diligence, one doesn't dive in into the deep end and spend a whole bunch of money, do a bunch of work. You might want to go incrementally. So for example, the other day, I get a call from a company we've done work for a number of times. They like acquiring properties, developing orchards. And for the first stab at it before they even get in under contract is they won't even know if it's worth their time, so they have us collect some soil cores. Where we just collect 1 foot increments down to 5 feet. That way we'll see where salts might be accumulating, where it's hard to auger. Oh, we've got a hard pan, etc. So by doing those increments, smaller increments, we have an idea of what's going on. Now, when you collect a sample with an auger, or Blake's favorite tool there, or I've got a favorite tool also with a foot pedal on it, you don't get to see the soil. You don't get to see what's going on underground, and that's the real advantage of doing backhoe pits and collecting samples from backhoe pits, is you get to see where you're collecting the samples from, rather than going with arbitrary, whether it's 20-inch increments like Blake likes, or 12-inch increments like I like. When you dig a backhoe pit, you see where the soil changes, and you can collect your samples from those breaks in the natural soil horizon, because usually where you see a color change, a texture change, a hardness change, there will be a chemistry, salinity, fertility change that corresponds with those textural or soil type changes. So that's really the key thing. And then, looking at your water quality. So, we're doing some due diligence for a company looking to, purchase some ground. First thing I do is I go on to the Google Earth Web Soil Survey, a wonderful tool overlaying the digital soil survey in Google Earth. So you see the satellite images, you can see where trees are weaker, and then you can see where soil types change. Do they correspond? It's how we decide where we're going to sample. So that's our smart sampling strategy, looking at where there's soil type changes and where there's crop growth changes. It's an incredibly powerful tool. It's available for free. So it helps us decide where we're going to sample. And looking at water quality is just as important. It's amazing how really poor soils, marginal soils, soils that it might have salt accumulation, if there is good quality irrigation water, what the trees are seeing in their root system is really that soil water solution. So good quality water can really turn things around. This same company had us look at some property in the Delta on an island below sea level for planting almonds. I told them they were crazy. Well, you know what? I was wrong. Never say never. First time I was out there, I got stuck in the mud. My truck didn't get stuck. My feet got stuck. I was ready to walk out of that field, leaving my boots behind. That's how wet it was. You know, the water table was almost up to the surface in the wintertime. It was corn ground, and there was a lot of salt accumulation, and I did not recommend it for planting any type of permanent crop. Well, I gave them data. They didn't like my conclusion. And what they did was they put in drainage, subsurface drainage. It's like, why would you put in subsurface drainage below sea level? Those pumps are going to run 24/7, 365. Well, their philosophy was, we're buying the land cheap, the good ground's all more expensive, and we're just going to cost the installation and running of the drainage sumps, we're just going to cost it out per acre. And that's what they did. And they planted trees, and I went out there and I was dumbfounded. So a lot of things are possible with enough inputs. But it all comes back to doing your homework, which is really important. Now, when I was first invited to this meeting, I was under the impression it was all about soil health, and I thought, gosh, I'm just, your standard agronomist, and I'm trying to learn about soil health as much as anybody else here. And we get a lot of inquiries at our laboratory about, tests for soil health, and there's a lot of things that can be tested, and there's this soil health manual out of Cornell University, and all of their tests are based on East Coast methodologies. So in yes, that is correct. High rainfall, you're going to have acidic soils. So within the country, there are 4 different soil testing protocols. So what we do in our laboratory is the methods developed by the North American Proficiency Testing Program. That's a proficiency testing program for laboratories, and they've got 4 methods manuals for the country. So there's one for the western states, for the arid and semi-arid areas. There's one for the Midwest, one for the Northeast, and one for the Southeast. So it's really important to work with a lab that's in your area, not using Midwest protocols for California, and vice versa. So on the soil health parameters in that Cornell manual, there's a whole bunch of stuff, and Oregon State their lab is doing it as well, and I've seen some of the test results, and I've been looking at lab results, for 25 years, and I look at some of this soil health stuff, and I kind of scratch my head because we don't really understand how to interpret it. So there's some chemical tests that we can run in our lab, just simple things like total organic carbon. Well, what do those numbers mean? So I don't know. We run the test, and it's real important to know which test to run, and that one also has to account for carbonates if the pH is in the alkaline range. We do a fair amount of analytical work for people who are doing research on this, but me personally, I don't know how to interpret organic carbon numbers or carbon-nitrogen ratios in soil. We have a lot to learn, but and then there's physical parameters that are also talked about a lot with soil health. Even something as standard as soil bulk density, you really have to collect those samples with special tools and collect them carefully in order to have reliable results. And so with any type of analytical testing, it all starts with getting a good sample. If a good representative sample is not collected, it doesn't matter how accurate we are in the laboratory, doesn't matter how astute I think I am as a crop advisor, if the sample wasn't taken properly and it's not representative of field conditions or localized conditions, everything is downhill from there. So sampling, smart sampling is really key. Other parameters might include water aggregates, stable aggregates. Then there's biological parameters, soil respiration, nitrogen net mineralization, enzymatic activity. A lot of these things we don't really understand very well. So we are going to be putting in a proposal with UC Davis to study some of these and really, tests. We can generate numbers, but what do they mean is the important thing, and having interpretation. So we've got, really good interpretation for a lot of our chemical, salinity, nutrient parameters, but some of these physical, biological parameters, we really have a lot to learn about. So when we get to those topics here today, I'm here to learn as much as anybody else. So we are well ahead of schedule, and I think we should answer some questions.
Yeah, first an applause to Daniel too. A lot of really good insights. It's amazing how each of you keep bringing very key topics, key messages. Daniel was just talking about water quality and the importance of not only collecting a soil sample, but also using that information, the interpretation of that, and how we have values or thresholds for many of the things we sample, but in other ones we are still working on. So open for questions, comment, discussion. Go ahead, raise your hand.
The question was, it was talked about whether we should have shorter irrigations as opposed to longer irrigations. It's probably oversimplified in saying that. What some research is showing, and again, is that oftentimes when we look at like soil moisture graphs, we used to look at those lower 4 and 5 foot areas and say that's dry and we want to push water there. That's kind of gone out the window and saying it's okay to have those dry areas. In reality, in most of our trees, we're really farming the top 18 inches or 2 feet, even for the mature trees. And so the idea that we're going to push water deeper, we see it in the winter rains, and there are some limitations in that, but I don't think that running really long sets, 24, 38, however length it is, sets is a solution to that. And I don't know if that's necessary, because when we see those lower 4 and 5 foot or whatever dry, that's okay. I mean, there's oxygen there. Those roots are, because we're keeping a fairly saturated, not saturated, but pretty wet area in the top so many feet. So having it dry underneath is sometimes okay. That's my point.
I was going to add to it.
Now, so was I.
But Blake, none of us will get a word in edgewise after you. Yeah. So, yes. As far as deep moisture, one thing I learned in school, and I've verified it looking at soil moisture readings, is the 40-30-20-10 rule. And that is, if you take your root zone and divide it into quarters, and we're going to keep the math real simple here. We're going to talk about a mature orchard, a 4-foot root zone. So each quarter of the root zone is 1 foot. So 40% of your water and nutrient uptake is from the top quarter. 30% is from the next quarter, and then 20 and 10. And where it really hits home is when you look at the top half of your root zone. So just because you got roots down to 4 feet, you got 40% of the activity in the top foot, 30% in the second foot, and you add those two up, in the top half of your root zone is 70% of your root activity and nutrient uptake. So that's really why keeping it up top is extremely important. And then, on fine textured soils and micro sprinklers, you're never going to push water down past that second foot anyway. But one real advantage of the dual line drip is getting the water deeper, and that's going to hold your trees over through harvest much better. But with new trees, you're really going to be wanting to keep that moisture in that top foot. And that's where those light frequent applications come in.
What I've got to say is as with so many of the factors we're talking about, the correct answer to that question is adult diapers. Depends. And it depends on a whole hell of a lot of factors. The 4,000-pound yields I showed you in that handout came from a field where 30% of my transpiration was pulled back out of the 3 to 5 foot depth because it was just that beautiful a dirt. Every third irrigation with the fan jets, in order to give me recharge down to 4 foot, was 48 hours. But that's because God never made better dirt than this stuff. For water holding capacity, nutrient, we never had ponding issues. So here, you've got a lot of rotator systems, sprinklers for frost protection, which are really neat. And that's your common irrigation method. Now you're wetting almost 100% of the orchard floor. I just heard the beginning of this week that I think Glenn Calusa, USBR, said that you guys are only going to get a foot of canal water this year. That's what I heard. Okay, now you're dealing with trying to get as much water as possible to the transpiration, not the evaporation. That's the ET. So everything these guys have said is absolutely correct. And the more you can hone in on the best management of the top 2 foot, maybe 3 foot, that's absolutely the way to go. But if I'm wetting 100% of the orchard floor, and I'm only going to put on 4/10 of an inch instead of a full inch, easily my evaporation can be 2/10 of that. It can be half of what I put on that didn't go through the trees. So consider that. Get your soil probe out. Check out if you got infiltration problems. That's another issue. Amendment. So, at any rate, that's the critical thing.
Thank you. Depends. Wow. Geez. I don't want to steal from the next group that's going to talk about the irrigation, but in my experience, the monitoring of the soil moisture with a capacitance style probe or something that is giving you continuous readings at multiple depths was really an eye-opener for me in terms of irrigation management. And so, there is no pat answer to that question. You have to understand your soil texture, the profile development, and then you have to go out and measure it, in my opinion, to really understand. I mean, the trees and the irrigation action that you're putting on that soil is going to tell you exactly how the tree will tell you. I mean, with the continuous monitoring, you're able to see as soon as the sun comes up, the transpiration begins, and you can watch the ET by layer take place. And as soon as you've drained out that top foot that Daniel was talking about, you'll see that you're no longer withdrawing moisture, and that line flattens out. But now the root uptake is happening deeper in the profile, and you can watch that biologically happen. You've got that biological signature with the day length, with evapotranspiration, that is telling you where root activity is taking place and how effective your irrigation was. I can't speak enough for that soil moisture monitoring on a continuous basis to tell you exactly what to do. Once you get 50% depletion, you better get your water on there. But, the deeper parts of your profile are going to be for salt management and making sure that you're moving those ions, the sodium chloride, past the root zone, trying to make sure that we don't build up too much there. But you also want to make sure you maintain the nitrogen in the profile. So it's this balancing act, but if you're not measuring it, you're just flying blind again. So thank you.
Yeah, so very good question. A lot of very good arguments for why to keep the nutrients where the active roots are. And perhaps a practical point here is also, when fertigating, try to inject the fertilizer towards the end of your irrigation cycle instead of the beginning. You know, I mean, all of these arguments go in that direction as well. So very good points. So we had more time for one quick question, maybe. There's one here. So go ahead.
Okay. Recommending lime on soils that have a pH above 6 really bugs the heck out of me. So and I don't want to get political here, but really that has been something that I've tried to fight for my entire career. You know, I know that our previous speaker mentioned the Albrecht stuff and the exchangeable bases and the ideal base cation ratios, and I've fought that my entire career. And over application of limestone when it's not necessary, I think is a crime. I think it's ridiculous, and so it really upsets me. And I could use some depends when we get into that topic. So. You know, really, yeah, I think you apply limestone when the soil pH is below 6, and you apply the appropriate amount of limestone, and I think calcium is important, but I think over-application of lime, no matter what the situation, I think is criminal. And I really need to stop there, because I'm starting to tremble.
I want to ask you a question. What's wrong with applying lime if your pH is in that 6 to 7 range?
So when you look at the solubility of limestone, really it's logarithmically decreasing as pH increases. And so to me, I think at that 6 range, if I need calcium supplied, because I'm not really necessarily needing to change that pH. I mean, want to monitor it year after year after year, because if it gets below 6, then we have a problem. But at 6, gypsum and limestone solubility is starting to get right about equal. Solubility of gypsum doesn't change with pH, but limestone sure as heck does. You put that limestone on, and it's just going to be a rock there, and you could overdo it. You know, I mean, the quantities of limestone that were being recommended by this person you mentioned, you know, basically you're going to end up with Lyme-induced chlorosis. You're going to have problems with mineral availability, especially iron, zinc, manganese, copper. You know, you're really going to cause some real issues in your soil by overcorrecting. So use the right amendment in the right situation with a soil test, and you're going to be a lot better off. I'm starting to choke up. I'm so angry. So, but that's a personal thing. I mean, I've fought this my entire career, so I'm going to hand it over to somebody else.
Well, and honest answer too. So thank you. Yeah. Thank you so much. I think we have one more minute. Do we have any more questions over there? Oh, there's one. Rob.
The question is, how can we manage our soil chemistry to manage and enhance our soil health? Correct? And yeah. Exactly. You know, calcium, whether it's from gypsum or limestone, depending on the pH, those amendments are going to increase your soil calcium levels, which will help improve your soil structure and aggregates. So yes, absolutely there are certain soil chemical parameters like salinity is going to decrease your soil structure if you have too much sodium. So having that additional calcium to keep, displace excess sodium and maintain good soil aggregation, that's important, as is organic matter. So there are a lot of interactions between your soil chemistry and your other quote-unquote soil health parameters.
One very quick comment on that. One thing most of us tend to forget when we think about soil chemistry impacts is we talk about classical flocculation of clays as a factor of available calcium. And the calcium helps to glue together those aggregates. But for a lot of our silt loam and the silt particles, the sand particles, don't have positive, or they don't have exchange sites on them to work with that. So how do you get the aggregation in that setting? you encourage biological activity. And one thing we do not have good tests for is how do I build the potential to improve my aggregation in an infiltration problem soil by adding compost, by maybe doing whole orchard recycling on that. All those factors end up with not only a chemical but a biological. The bacterial exudates, I mean, bacteria shit can be important sometimes to help glue together the particles to make good aggregates and move the water through. So that, yeah. Last thing I would ask this guy right here, Sebastian, he hasn't said anything. This guy is the one who is one of the major people responsible for our current nitrogen standards in almond production. So how do these guys manage their nitrogen for this coming year if they, say, had 30% frost damage, 80% frost damage? What do they do?
I was going to end the session, but I got to answer that one. Well, the first thing is walk your orchards and estimate your yields, because a lot of what you need to apply depends on how much you're going to produce. So don't do a blind application. I think that's the worst thing you can do. A blind application with the price of fertilizers, and even now that you may have less pounds than what you were expecting, is really put you at the wrong side of the equation. So walk your orchards, try to get a good sense of how much you're going to produce. You know, it doesn't have to be exact, but it's going to help you a lot to do your nutrient planning and take it from there. So do an estimation now, apply according to that, and then the next month do it again. And as the season progresses, you're going to get more precise. The instructions on how to do it, you can follow them here. So thanks for the question, and thanks to you guys. Yeah, very good.